Hello, good afternoon. I actually want to continue maybe on a workshop and on the last thoughts you had, just how the humans will look like in 2084 and actually what the future is. And we don't really know, but if we listen to one of the Google's visionary directors, Ray Kurzweil, actually we will reach soon the point which is called singularity, where the human will be less intelligent than a machine. Machines will become more powerful and more intelligent than we are, he predicts, by 2045. So if this is true, then many hope that actually when this happens, we will actually become immortal. And if we become immortal, what will happen? Whether we will have enough space on Earth, whether we will have enough food, how the life will look like. Some of them think that actually we will become a humanoid with a brain connected to a cloud, and we will stock our information there and retrieve them to think about things, that we will get empowered by different technology tools to actually live forever. Maybe we will look like a chips, just with a face, and everything else will become less important. I don't really know. What I would like to tell you about today is actually more about what binds me to precision medicine, what is my passion. And my passion is more about actually increasing quality of human life and providing a better care to people. And that is, for me, what is a precision medicine is about. So, before I start speaking about precision medicine, I'd like to ask you one question. Did you ever experience a situation you have a terrible headache, really terrible headache, and you forgot to take your pill, a painkiller? And people around you notice something is wrong and they tell you, oh, do you want a painkiller? I have one. And they give you one and you say, oh, thanks, and you take it. 5 minutes passes, 10 minutes, half an hour, 45 minutes, nothing happened. Your headache is still there. Did you ever have it? Well, actually, that happens very, very, very often. Why? Because we're giving all people the same drugs, the same dosing of drugs, but actually 90% of the registered drugs are effective only in 40% of people. So that's the average. For some therapies, the situation is a bit better. For instance, antidepressants don't work only in 38% of people, but for instance, anti-cancer drugs, for many of them, 75% of time are not efficient. So that's what actually brought the question of personalized medicine. How do we know that the treatment will be efficient, and why? And how come that some people respond well to the treatment, but the others actually just experience horrible secondary effects? One thing I want to share with you that actually very rarely it's spoken in the public is that secondary or adverse drug effects are really serious healthcare problem today. Do you have any idea how many people actually die of adverse secondary effects? No? Well, WHO publishes every year a statistics of most deadly diseases, and if you look, well, heart diseases are still the worst. They kill around 8.8 million people. But then, surprisingly, in 2013, FDA published a study saying that every year around the world, adverse drug effects kill more people than diabetes, than car accidents, and certain types of cancer. So that places adverse drug effects to around 5th, 6th most deadly disease on Earth. And yet we don't speak about. So this, for me, represents what the personalized medicine should be about. And actually, we try to answer the questions how we can stratify patients, how we can find out for whom treatment will be effective, for whom it will be effective but also will have some adverse effects, and for whom the treatment will be completely ineffective. And based on this, then decide who should get the medication, who should be maybe examined whether the medication should be given or not, or who should not get that medication but something else. To come to there, actually, humanity went a long way, and there were a few technological revolutions that had to happen. First one was actually started with discovery of DNA, and actually just in roughly 50, 60 years, we came to the sequencing of human genome. The first human genome took more than 10 years to be sequenced, huge amount of money, but eventually in 2003, we got the full code published. So not that far away, just 15 years ago. What that brought us? It's a nice image from another TED conference by Riccardo Sabatini that I invite you to listen if you have time, which actually describes the human genome. And what you see here, all these books, is actually a human code printed in a book. So that's all our information, that's what we are, this set of books. What is really interesting is that with the sequencing of human genome, we learned many things, we confirmed certain things that we knew, but we learned many surprising things. So one of these things that was confirmed is that all our code contains only 4 letters, G, A, T, and C. We all composed our DNA of just 4 letters. We have 3 billion letters in our genome, but only 20,000 genes. When I was a student, I've been taught that we have 5 times more. So that was a huge surprise. We were as simple as some much simpler, physically simpler organisms like flies or insects. And we always thought, like human beings, that we might be superior and have more genes than the others. Not only that, we were really surprised because only 2% of human genome actually encodes for proteins. So everything else there is to regulate and to respond to environment, and for many parts of the genome we still don't know the function. Another very, very surprising thing. Look all these faces, how they're different. We are all different. Yet, if we look at the genetics, we are 99.9% identical. If you turn to your neighbor, you're just 0.01% different. How much is that? 3 million letters? Is that a lot? 3 million letters? It's enough to make each of us unique. So that's what is the difference between us. And these differences, these polymorphisms, in genetics they're called polymorphisms, actually allowed us to identify or associate certain variations to certain phenotypes or expressions. One of those is, for instance, how we metabolize drugs. For this to be developed, we needed second technology revolution, which is actually machine learning. And you heard today a lot of machine learning. I just want to say that machine learning also has its good applications. It's not always just the bad applications. So it helped to associate, as I said, certain variations to certain outputs. We heard a lot over the last years about big data, and everybody speaks about big data and importance of big data and collecting data. I'd like to tell you a small anecdote that actually, in my view, we don't need a big data, we need a smart data, especially in medicine. And it was a study that finally was never published, but it was done in a New York hospital, where they tried to study the influence of a nutrition on the physical characteristic, nutrition of a mother during the pregnancy, on the physical characteristics of a newborn baby. And they found a revolutionary result that eating lots of rice, actually, especially 2-3 times per day during the pregnancy, will be associated with a higher likelihood that the child will have dark hairs, dark eyes of the oriental shape. Everybody was astonished. And then they looked a little bit deeper into data, and they found out, well, all the pregnant women for whom this was the case actually came from Chinatown, New York. So it's not just about big data, it's about smart data. So what I want to tell you is that You have a power to influence on that. If you go to hospital, somebody asks you, I want to collect your DNA. You should understand why it is for, what it should be used for, what are really the relevant data you should give, and not just share any data that you have. And the third revolution will come certainly from connected objects. We all spoke about smartphones and about social applications and social networks. There are many of these applications that actually take your physical characteristics, how much you walk during the day, what did you eat. All this is actually gathered to be used in medical studies. Well, what precision medicine can really do today? Well, it can do lots of things. It can, as I told you, already now say for the vast majority of drugs that are commonly used, whether you should take it or not, what is the dosage that should be given, how it should be combined with the other drugs. Through the algorithms that are developed, you can actually predict how a person will respond to a drug. Certain diseases can be predicted. People always speak about cancer on purpose. I don't want to talk about it. For instance, there is a glaucoma, a terrible disease that leads to people lose their sight when they're older. Well, you can actually predict who is going to get glaucoma. And you can prevent it by a simple surgery intervention, where people will get actually a small intervention on the optical nerve, and they will not develop disease. So precision medicine is all about this. It's about preventing the disease before it happens, and it's actually something that existed a long time ago. And Avicenne, who is one of the fathers of medicine, who lived in the 10th century, already said in his poem of medicine that medicine is actually art of preserving health and eventually of curing the disease that might occur in a human body. What is the impact of precision medicine in general? Well, there are many impacts. There is impact on a clinical decision, on a patient life, on a society, on an industry, on all of us. I'll give you an example. We developed a tool to actually predict who will develop blood clots with contraceptive pills. It's the most widely used contraceptive method in the world. 100 million women are using it. And yet, some women, it's very rare, 1 in 1,000 of users, will develop blood clots. And why it is important? What is the impact of such a tool, precision medicine tool? So basically, with such a precision medicine tool, you can choose what is the most optimal contraception for a woman. You can choose what is the best mode of delivery for the hormones, for instance, whether it's oral or whether it's a patch or whether it's something else. You can say what is the best intervention moment. The risk of blood clotting increases with the age for every single person on the earth. So you can see, okay, this is the threshold until which we can go. So maybe I can treat this person until that age, and another person for 10 years more, and another person shouldn't get it at all. But you can actually decide upon a time that is suitable for the treatment. And also, you can know treatment responses. What is the impact of the patient? Well, this kind of problem, for instance, blood clotting, can happen very early. Girls of 16 can have it. They stay disabled for the rest of their life. Well, if we can avoid it, we significantly impact of the quality of their life. Also on the compliance they might have to the treatment, to the therapy, but that's true for any therapy with the precision medicine. If we speak about impact on the society, well, if we have less blood clotting, we will have less healthcare burden. So healthcare will become cheaper. As well, quality of life will increase, there will be less absence time of work. So we can, in general, bring quality to society. Also for the industry, it's very interesting, because industry can improve development process, can use such a test to test ahead of putting on the market a pill, to say, well, this pill is less dangerous, so I'm going to use that one. Also, it can, in specific cases, improve, for instance, intellectual property for the companies, who can narrow down the application of a certain drug and then have their IP extended. Even if we can do today a lot with precision medicine, there are still many challenges, and I just want to share some with you. Clinical utility. When we develop such a tools, one shouldn't lose from sight that it has to be a useful tool, clinically useful, so that we can actually bring better life, better quality of life, better care to patients. Costs, they are still fairly expensive treatments, but the prices is getting down with the technology development. And hopefully one day, precision medicine should be accessible to every single person on the earth. Understanding probabilities, that's very important. If you don't understand probabilities, you can't match the expectations. And I'd like to come back to one of the talks we listened this morning, saying, well, if I give my DNA, then my genetic information will be available to my insurance company, and my insurance company will increase my due that I have to pay. And everybody gets scared of it. But actually, you have to understand that no progress will come if we don't give anything, if we just are scared of everything. So if we scare people all the time about the insurance, then people will refuse, for instance, a treatment that can increase their quality of life or save their life. So everything, actually, for me, is in acceptance, and to have acceptance, we have to have education. Everything is about the education. Explaining to everyone what it is really about, what do they give, so that the people can actually impact through their acts on legal decisions and on the ethical decisions. Thank you very much.